For question 2, we have a bunch of new things. So we have the we'll call capital D and lowercase d. Capital D would signify the diameter of the bulb, so 0.2 centimeters, which we'll also say is the same as 0.2 over 100 meters. We also have the diameter of the tube, which is 0.004 centimeters, which is the same as 0.004 meters, over 100 meters. Cool. Now we also have the linear expansion coefficient, which is alpha. And of course, we need to make sure that it's the alpha of the glass, which is 3.0 times 10 negative 6. We also have the volume expansion, which is, of course, of mercury, which is 182 times 10 to the negative 6. Now, the question is asking us to find the height to which our mercury rises. So it goes from here to here plus this additional part. So it wants us to find kind of the volume that this additional mercury takes, right? So conceptually, we know that, by looking at these two kind of values. Oh, sorry, let's rewrite that. It's a beta. Okay. Now from here, even if beta and alpha are two separate things, we can see that beta is significantly bigger than alpha, which means that mercury expands far quicker than glass does. So from there, we can start making some assumptions. We'll say that the additional mercury we'll have will be equal to the final volume of glass minus the final volume of mercury. Right? Actually, let's rewrite this. So it'd be final volume of mercury minus final volume of glass. And we know this to be true because if we have mercury expanding much quicker than the glass, then we'll have some additional amount of mercury that kind of overflows from the glass. So if we have this glass and we have it filled with mercury, so glass filled with mercury, then it'll expand out and kind of leave the glass bulb because there's too much mercury that's expanded that can't fit into the volume of the glass, right? So where would that additional mercury go? Well, we know it would go into this portion of the tube. So we'll make some more statements. So we know that initial volume of glass is the same as the volume of a sphere, which is 4 pi r squared, right? We can also say the initial volume of mercury, is the same as the volume of glass initially. Now, why can we say this? Well, we see that just focusing on this part, we see that the only mercury we have takes up the space of the bulb. Now that means that we have an equal amount of mercury to the volume of glass, right? So from there we can actually make this statement. Now, of course, we need to make the final statements. So volume 2 of glass, of course, and volume 2 of mercury, right? Now we also know that this is the same as the initial volume of glass, initial volume of mercury, of course, and then plus its change of volume, the respective changes of volume, right? And so that becomes V1 glass plus beta times beta of glass, of course, V1 glass times the change in temperature of glass. Of course, that's the same, but we'll just denote it just to be specific. You have V initial of mercury plus beta, of course, beta of mercury times V initial of mercury times the change in T mercury. Cool. And now we also know that the initial volume of mercury is the same as this. So we also get that V1 glass plus beta of mercury times V1 glass times the change in temperature of mercury. So we'll simplify this again. V1 glass times 1 plus beta of mercury times the change in temperature. All right, and this is what we can simplify. This becomes the initial glass times 1 plus beta of glass times the change in temperature. Cool. Just a correction. We don't use beta. It's gamma, actually. So, of course, when it comes to volume, it's not beta, it's gamma. So we'll rewrite all of these. All right. Cool. So now we have these two expressions for our final glass, or final volume of glass, final volume of mercury. Now, from here, since we have all three equations, we can start simplifying this equation right here. Or sorry, no, we can simplify this equation right here. Because this becomes the following. Let's copy this. Right, so we put it here. Now V2 of Mercury is of course this statement. Of course, and also V2 of glass is this statement. So now from here, we can just say that it's this statement minus this statement. And of course, we can simplify some things. So we get that V1 glass times 1 minus 1 plus gamma of change in temperature minus gamma, sorry, gamma of glass change in temperature. Now we can also say that it's V1 times the change in temperature times alpha of Hg minus alpha of glass. Cool. And now we also have to make another distinction that we don't have the volumetric expansion of glass, but we do have the linear expansion. Now again, going back to this relationship, you know that gamma is 2 alpha. So we write this part right here as V1 of glass times temperature times alpha mercury minus 2 of alpha glass. Alpha glass. Now we know this is the additional volume of mercury you'll have, right? Now from here we can say that we know that volume is equal to base times height, right? And so the base would be 2 pi r squared, 2 pi r, sorry, core squared times the height of the tube, right? Now here, of course, we're solving for the height of the tube itself. So the volume of the tube is given by this equation. And since we're solving for h, we have v over 2 pi r squared equal to h. And now, of course, we know v to be this expression. So let's substitute that back in. And we get that v1 over, sorry, times the change in temperature of the system times the gamma of Hg minus 2 alpha of glass. And of course, this is all over 2 pi r squared. Awesome. So this would be our final equation for figuring out h, and all you'd have to do is plug in values. Quick correction, the volume is not 4 pi r cubed squared, it's 4 over 3 pi r cubed, which makes a lot more sense, because it's three-dimensional, right? But everything else should still stand. So if you want to plug back in what V1 of glass is for a more finalized equation, we get that 4 over 3 times pi r cubed times the change in temperature of the system, and then times, of course, the gamma of mercury minus 2 alpha of glass, and of course all over 2 pi r squared. And of course, from here, the pi's cancel out, this r cancels out, and one of these 2's cancel out. So our final equation becomes 2 over 3 r times the temperature of the system times gamma Hg minus 2 alpha of glass. Cool. But of course, you could have plugged in any numbers at any point in the stage during the solving stage, but it's good to have a kind of final simple equation. And of course, we'll also say that since we only have diameters, we have 2 over 3 times diameter over 2. So these 2's will cancel out. So let's simplify again. So we have diameter over 3 times the change in temperature of the system times, of course, gamma of mercury minus 2 alpha of glass. So that's our final equation. And of course, this is the diameter of the glass.